Okay, so this is the third lesson in the matrices unit, which is determinants and square matrices. We're going to break this into two different videos, one dealing with the determinant of a 2 by 2 matrix and one dealing with the determinant of a 3 by 3 matrix. So just this will be covering what is a square matrix and what is the determinant of a 2 by 2 matrix. So a square matrix is any matrix that has the same number of rows and columns. We discussed previously how matrices are always rectangular in shape. Well, if it's rectangular in shape, then more specifically it could be square in shape. So we're talking about matrices that have the same number of rows and columns. In other words, a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 4 matrix, meaning 2 rows, 2 columns, 3 rows and 3 columns, 4 rows and 4 columns, etc. These types of matrices have special applications, they have special properties to them, therefore they're worth studying independently. Now, one of the things that those matrices have is called a determinant. It's sort of kind of like an absolute value. The reason it's called a determinant is its value determines whether or not the matrix has an inverse. So we have to talk about, we have to crawl before we can walk. So we have to understand how to find the determinant of a matrix before we can talk about how that determinant is used in application. So for the purposes of this, we're going to be referring to a matrix A, which is going to contain 4 numbers. It's going to be a 2 by 2 matrix, A, B, C, D. There are 2 ways that they could ask for the determinant, notationally speaking. They could use the abbreviation DET for determinant, and then tell you what matrix to find the determinant of, in this case A. Or they could just simply write the matrix, only they could leave off the square brackets and use absolute value symbols. If they do that, that is telling you that they want you to find the determinant. Now, the rule for doing this is very, very, very simple. We're simply going to do top left times bottom right, or A times D, minus bottom left times top right, C times B. Now, for later on, when we talk about a 3 by 3 matrix, what we're doing here is we're dealing with the downward diagonal and the upward diagonal. The one I highlighted with yellow is known as the positive diagonal, and the one I highlighted with pink is known as the negative diagonal. Hence, A times D minus C times B, because this is a negative diagonal. So here we have a 2 by 2 matrix, 3, 5, 2, negative 4, and we are simply going to multiply 3 times negative 4, and then subtract 2 times 5. Because again, we have that positive diagonal, 3 times negative 4, and that negative diagonal, 2 times 5. So we simply multiply those and then simplify that down to a single number. That would be negative 12 minus 10, or negative 22. So that one number is our determinant for that matrix. So this lesson does include a few more examples. Here are matrices A, B, and C. You'll notice that they are all 2 by 2 matrices, and we're going to find the determinant of each one. So again, A is going to be 3 times 2 minus negative 5 times 8. Again, we're talking about a positive diagonal and a negative diagonal. So our positive diagonal for A is 3 times 2 minus negative 5 times 8. So we multiply that out. That would be 6 plus 40, or 46. Same thing for matrices B and C. For B, we're going to do 2 times 3 minus 1 times 6. Once again, that is the positive diagonal minus the negative diagonal. So that would be 6 minus 6, or 0. Finally, on C, we have negative 3 times negative 2 minus negative 5 times 4. That would be 6 plus 20, or 26. Again, positive diagonal minus negative diagonal. That does it for 2 by 2 matrices.